if you want to step up to be able to design databases like a professional, you must learn what's in this video. Learn SQL in simple English. This video looks at tables. All the code will be repeated at the end. Okay, so we're going to open our database and we're going to look at the tables. We started off with just a very simple table called friends. If you can remember, we had name, surname, we had scores from 2 weeks, week 1 and week 2. If you can remember in a previous video, we did a group by SQL statement and we found an error. So let's have a look at that SQL statement again. So we select name and we total the score up, sum score, and we're going to group by the name. And if we run that query, we'll see that there's 3 results, which seems okay. But wait a second. If we put the full name, the name and surname of the players, and we run it, we find that there was a mistake. There's 2 Johns and it added their scores together. So why did this happen? Well, what we need in a table is a unique identifier to make sure each player is identified uniquely. So in databases we use something called an identifier. It's also called a primary key. So we identify each individual row, each individual record by the identifier, the primary key. So to create our tables, to create our database, we really need to change our tables. So we're going to start off with create a table called player. So this is going to list our players. So we're going to start off with a player ID, which is a unique identifier for each player. We can have their name and surname in the same table. So we can run that query. You can see the create table SQL, and if we have a look, we've got the table, but we haven't actually got any data in there. So we can easily move data in now. We can use that in using SQL statements, or for ease we can copy it in using SQL line. So if we have a look at player, we can look at the table definition, and you can see here we've got other alternatives. We have not null, we have unique, we have AI, which stands for auto increment, and PK stands for primary key. So in the create table SQL statement, we can add different parts of the SQL. So we have not null, primary key, auto increment, and unique. So these are called constraints of the table. So now with our new table called player, we can create 8 rows, and from friends we can copy and paste in the names and surnames into our table. So now we have the table with 8 rows. We can use SQL to check our data, so we can do a simple select all statement. And if we have a look, what have we done here? Well, we've got the names duplicated. That's not what we wanted. So if you want to remove data, you can use the delete from SQL statement. So here we delete everything. So delete from deletes delete from, and then the table name deletes everything from the table. So we go back to our table player and copy in the 4 players, not 8, the 4 players. You might notice the increment number has gone up, if you like, from 1 to 8, it's carried on 9 to 12. So this number is not really relevant. The fact that it's unique is the most important part. So we go back to our table definition. You can see it's a primary key, and auto increment means it's going up a number, up by 1 in a number. The database creates the number for us. That's the auto increment. So now let's create another table of points. So we're going to have another primary key, and then we're going to have our scores. You can see we have other options. Default, which means if we don't put anything in, it will give this default value. We have check, which means that we can check to see if a value meets a certain constraint, if it's greater than 0 or something like that. And also foreign key. So we create our score and week columns. They are both integers, and you can see the SQL create table definition. The SQL is there in front of you. So we can use this SQL to create tables. There are other data types as well. Integer, we have other types such as text we used for the name and surname. So have a look. We have our players, and now we have the points, which is empty. So we can get that data from our previous friends table. We can copy that in. If you want to use SQL, you can use the insert statement. For ease in this video, we're just going to use the SQLite method and paste in now, and you can see now we have the score. So we've got player details like name and surname in the players table, and we've got the score details in the points table. So we want to be able to look at the both tables together, which we can do in a simple select statement. So we want to select, for example, we can select all from points. We can see everything in points. Yeah. But we haven't got a player in there. So we need to put the player ID in the table of points so we know which player has got what points. So we go back to the create table statement, and then we create the player's ID into the points table. So we now know which player scores which points. So the link between the player table and the points table is the player ID. So now we go back to our select SQL statement. We're going to select everything from points and player. We do that, you'll see we return 32 rows. It's kind of like everything in points multiplied by everything in player, which is not really what we want. You can see we have the player ID. We've put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is wrong. We need the correct player ID. So the 4 players had the IDs of 9, 10 and 11. So we can go back and change them. And now when we run it, we can see that the player ID is the same in both tables. But again, in our SQL statement, we return 32 rows. So what we need to do, we need to match the player ID in both tables. So we add a where clause. So where points.playerID equals player.playerID. So now we know which rows are supposed to be together. So when we run that query, there's 8 rows. So result set is now 8, and you can see the player IDs match, which is what we wanted. here's a problem though. We're just going to add another record to our points table. So we add a score, we add a week, and we're going to add an incorrect player ID. And when we enter that, there was no error message. Nothing bad happened, which is a mistake because we don't want to enter a player that doesn't exist. We want it to check the players table and to make sure the players in the players table. So that's wrong. There's something more we need to do. So if we go back to our points table, we look at our create table SQL, we can see we've got player ID there, but we need it to be a foreign key. So the primary key for the player table, we want it to be a foreign key in the points table. So when we enter details about the score and the week in the points table, we want to link it to the player in the player table, and we do that with the player ID. So the player ID is the primary key in the players table, and it's the foreign key in the points table. That represents this relationship between the two tables. There are other table SQL parts we're not looking at today, but the main thing we need to check when we've created our code with the foreign key is that we've got the foreign key, the table name and the column name correct, that matches the foreign key in one table to the primary key in the other table. So here you see foreign key and then the column name references, then the table name and the column name. I hope that makes sense. So now if we go back and try to enter a record into our points and we put in a user that doesn't exist, here we go. Now we've got an error message saying that the foreign key says that's not correct. So that's what we want. So if we go back to our SQL, when we look at the two tables together, now we should be able to see the correct information. So we're going to look at name, surname, score and week. So this is going to end up with the identical information that we had in Friends, but now our database design is much better. When we try to do SQL statements, we won't get mistakes like we did before. So this is a crucial part of database design and creating SQL statements. Finally, there are other table SQL statements. You can alter a table, you can change columns, or you can even change the table name. So here, for example, we alter table friends and we rename it to old friends. So there are other table commands called alter table. We've seen delete from table, and there's also drop table if you want to completely remove the table. So there's an example of alter table. You can change column names and add things to a table using alter table. And here's an example of drop table. So drop table and the table name, we run that. We can see the SQL's run successfully, and now that table's gone. So delete from deletes all the data, and drop gets rid of the table completely. So finally we're going to go back to our points table, and remember we said we could have a default value and we could also check a constraint. We're going to put in these. We can have a null value, so when the score is not entered, rather than being given 0, we can have a null value, which will be explained in another video. And another constraint we can add is a check constraint. So this example, the week we want between 1 and 52. So we want it to be a number between 1 and 52. So when we enter data into our table, it makes sure that we don't make a mistake. This is called data integrity, which is another very important part of database design. So now we've got our data the same as we had before with friends, but now we've got foreign keys, primary keys with relationship between tables, and also we've got data integrity. So these are very important parts of a relational database. Again, we can check our data, and this time rather than type out all of the table names of player and points, we can use the alias. We've seen the alias before, but now we're going to call the tables player, we're going to call P, and points we're going to call PO, and we can use those aliases in the where clause, and that will give us the same data. So that's tables, a very important part of SQL, very important part of database design. So I hope you understood what was covered in here. We looked at tables, we looked at a unique, meaning no duplicates, not null, meaning you must enter a value, primary key is the identifier of a table, and auto increment means we don't have to enter any primary key. The system will give us a automatic number starting from 1 going up 1, 2, 3, etc. So that was the create table. Okay, I hope again that you understood that, because it's very important. And please, if you have any questions, leave a comment, and of course, if you haven't already, please subscribe. Now for the code review.